Okay, I think this is recording. It didn't count me down, but hi. Sorry, I just remembered. Okay. Welcome to us going over the mock. Okay, so we are on question 6 on paper 1, okay? I see a yellow ball slowly rolling away in my field of vision. Okay. All right, so set up your calculator, right? We've got sine and cosine. Our t-axis goes from 0 to 4, so what mode should you guys be in? Radians. All right, cool. Here we go. Oh, this is paper 1. Sorry. Never mind. Okay. So, we are reading the problem, and it says, the displacement in meters of the particle from the origin at time t is given by this guy from 0 to 4. This is shown in the following diagram. Point A shows the particle's displacement. All right, so this is S of t after t equals pi over 3 seconds. And point B, okay, so this is A, and he's at pi over 3. Make sure if you didn't mark that down on your graph, you put it there. And then B is the particle's displacement after 2 pi over 3. All right, cool. Show that the displacement of P from O can be expressed as sine 2t times t minus 7 over 2. So the command term show is going to tell me that I start with what was given. I'm going to try to match this structure over here. Some of you guys did a little bit of math magic. I'm not entirely sure how you arrived at this structure here. So let's just make sure we're all on the same page, okay? I'm starting with t, or S of t equals, what did it start with? T sine 2t minus 7 sine t cosine of t. Okay, so when we have factor times factor, that tells me that I've pulled out a what? What have I pulled out in order to get factor times factor? A common term, a GCF, right? One of those GCFs happens to be sine 2t, right? So I already have a sine 2t here. What are you going to need to do with this guy? Rewrite him as a double angle, which is fine because we see sine t times cosine t. That should be like, oh yeah, I can see that. But this is the part where some kids kind of did weird stuff, right? If I take that coefficient of 7 and I need to get a 2 out of it, can't I just divide this by 2 and then put the 2 over here? Yeah, I can, right? And then now I've got this. So I feel like that was probably the piece that was missing for most kids. They didn't know how to get that 2 over with the double and then didn't know what happened with the 7, okay? I invented it. So you needed to like pull that 2 out on your own because that's the only way you could match the structure of a sine double angle, which is what we see as the GCF. So you're basically just like, how do I invent a coefficient of 2 out front? Well, I could divide that 7 by 2 and then multiply it by 2 afterwards. Wouldn't that come out with the same thing? Yeah, it would, right? So how did you get that? I invented it. Okay. So now I'm like, oh, okay. Now I'm going to turn this guy into that double angle that I need. Okay? And then now I'm going to pull out that sine 2t, and then I get my 2 factors that I need, okay? Oh, wait, sorry. I meant to pull out the sine 2t. Okay. Now, it says, show that for t is greater than 0, the particle first passes through the origin at t equals pi over 2. So when we're given the displacement curve, this particle is passing through the origin when it crosses over the x-axis, right? Okay, so it's when it hits 0, right? Think about the origin as 0. When it passes back through that 0, that's when it's passing through the origin, okay? Now it's heading up to the right. And then over here, it was to the left of the origin. This is the origin. Yeah? Okay. So what do you think I could do algebraically to find out what that point is? I'm going to take the displacement function. I'm going to set it equal to 0. I'm going to solve, right? Which is the easier version to set equal to 0 and solve? This guy or the one where you just factored out a GCF and you have factor times factor? The one where you factored out a GCF and you have factor times factor, okay? So I'm going to take this version here and work with it because it's way easier. So now I have the sine of 2t times t minus 7 over 2. And that's set equal to 0. Why am I setting it equal to 0? I want to see where it passes through the origin. X-axis. Good job. So now, this is how you would earn full credit on this guy, right? You have t minus 7 over 2 equals 0. Some of you guys got this solution, but you didn't explicitly reject it. You would have to show that you would explicitly reject this solution because it is not the first time. You could just write reject, or you could write not the first time. This is not the first time it passes through the origin. That is, in fact, this guy right over here. How do we know that? Because he's greater than the first solution that we get, which is going to be, okay, sine of 2t equals 0. When does sine equal 0? At 0, pi, and then back again at 2 pi, right? So 0, pi, 2 pi. Except we have a double angle here, so it's going to be, these are our u's essentially, right? And then now we got to figure out which ones make the most sense. Which one are we trying to get to? Pi over 2, right? What do we know this has to be less than? This has to be less than what? 2 pi over 3, right? So if I set each one of these equal to the solutions that I have, sorry, 2t equals 2 pi. Yeah, come on, right? I would get t equals 0. Are we going to keep that one? No, right? Because that is where the interval starts. I'm going to try this one. Oh, heck yeah, that's the one I want, right? And then I divide this by 2, and I get t equals pi. That's greater than 2 pi over 3. So I reject these guys. I keep this. That's exactly what I was trying to show. Okay? Any questions? No? All right. Cool. The last one. Oh, no. This is C. Last two. Find the velocity of the particle at this time. Most of you guys were able to cook out that the velocity is the derivative of the position function, but then you forgot at this time. What do you think it's referring to when it says at this time? When t equals pi over 2. Okay, so that's the at this time part, okay? And the velocity is going to come from, the derivative of the position function, okay? So which version are you going to use? I think you guys used this one. Some of you guys did. Why is this one kind of more difficult than the other version? This has 2 product rules in it. You have to use a product rule for the first piece because it's t times the sine of 2t. Then you have to use the product rule again for the second piece, sine t times cosine t. There's an easier version of this position function to work with, and it is the factored form right here. Why is that easier? Because if you have this as your position function, what is it again? It's 2t sine of 2t times t minus 7 over 2. How many times do I have to use the product rule to find the derivative of this guy? Just once, right? This is u, this is v. So I'm going to set up my u prime v plus uv prime. So if you didn't get this right the first time, if I were you, I would either write it on the test or on a blank sheet of paper next to it. Try to get the numbers together. And then I know that on the next part, on D, maybe like 3 kids got the answer right. So you're probably going to want to get an extra sheet of paper so you can work on it on your own and try to get those numbers right, okay? Dylan, did you get D right?
No.
Who got D right? Mackenzie, you got D right?
No, I just didn't make it negative.
Did you get D
I
right?
did the same thing. I flipped the sign.
Someone got D right, and I threw your paper across the room. I was so excited. Maybe they're not in here. It was you? Oh. All right. So here we go. Go ahead. Let's do it now. We'll do it off to the side, right? The derivative of sine is Wow, thanks guys. Is cosine. And then what did a bunch of you forget? Times the derivative of the inside, times the 2, okay? All right, so now you would have all right, and then once we have this version here, we should substitute in A. Substitute in A.
I didn't do it.
Well, now that you have it, what should you do? Because you have to find the velocity of the particle at this time. Pi over 2. Good job.
Pi over 2.
Did anyone get the derivative right when they did it with the double product rule, where you had to do it 2 times? The answer was 7 minus pi. No.
Wait, what did she ask?
Wait, what did you
Double
ask?
product?
Like, did anyone do it with the harder version to do it with, where you have to do the product rule 2 times?
Oh, I tried to check it with that, but it was a mess.
Oh, I saw you, and then you were like, yeah.
Wait, so if you're going from distance to velocity to the derivative,
Displacement or position, they're the same thing. Yeah.
and
Mhm.
then like velocity to accelerations is
The derivative again, and then it's the opposite when you're integrating. Yep.
okay, because I got that wrong.
You can remember SVA. Position is S, velocity,
Because I
acceleration.
did the opposite. I integrated to get.
Oh no, you did. Oh dang. Okay, so now you would have V of pi over 2 is equal to. So the 2's are going to cancel here. What's the cosine of pi?
0.
-1 times a 2 is -2, right? And then you have pi minus 7 over 2. And then the 2's are going to cancel here. What's the sign of pi?
0.
0. Okay, so now these are going to cancel, and I just have negative pi minus 7. I think people who got it mostly right, I think you had negative pi. You could have it this way, or you could have it this way. Both are correct. Okay.
Like, are those the two answers you should have gotten, or is it like one or the other?
They're both equivalent. It's the same thing as writing like negative 3 plus x or x minus 3.
Oh,
They're the same thing.
I did not read. Oh, I see it.
Yeah. Oh, excuse you. Are you okay?
Where's Jason?
You spit all over.
You made a fart sound, and then where's Jason?
Right there!
How do you think he'd feel? He probably wouldn't care at all, actually. Okay. So now find the total distance traveled by P between point A and point B. All right, we're going to have full participation on this question. Do you have a piece of paper? Are you ready to cook it out on your own? Yeah? All right, good. So, I love the enthusiasm. All right. So we're trying to find the total distance traveled. How do you find the total distance traveled? It is the integral of the... Oh, yes.
I did that.
It's the absolute value of the integral of the velocity function, right? However, the test knows that you don't know how to integrate absolute value by hand. So the test is going to give you a part of the graph. Where is it? Between point A and B. Between point A and B. Okay. So the thing is going to show you here. I'll show you how it comes out in a minute. Okay. So we have the total distance traveled by P between A and B. So from A to B, what are those points? Those are my bounds of integration, right? What are those going to be? Yes. 2 pi over 3, good. Okay, so this graph is fully increasing. There's no backtracking here, so just think about that, right? If I integrated this velocity curve right here, what would I end up getting? What is the integral of the velocity curve if there's no backtracking? It's the change in position. It's the displacement from pi over 3 to 2 pi over 3. There was no backtracking. He just went up, right? So we could just find the distance between those two little parts by integrating the velocity curve and getting the position function. And that position function is going to be evaluated from 2 pi over 3 to pi over 3. Okay? So when I set this up, I now have 2 pi over 3 minus pi over 3. A lot of you guys earned quite a few points for just getting to this part because it shows that you you know what's going on, right? But you probably ran out of time or just whatever, right? Who got a bunch of points for getting to this spot? Yeah, good job. Okay. So then now from here, what do you need to figure out? You just got to figure out s of 2 pi over 3, s of pi over 3, and then you're going to subtract off the s of pi over 3. Okay? So not too bad. So go ahead. On your paper, try to work through it. You're going to calculate the s of 2 pi over 3, and then you're going to calculate the s of pi over 3. Okay? So I'll do it with you up here, but you can stop listening if I'm distracting you, and you can just keep going on your own. Okay? So let's see, where's the position function? I think I'm going to want to use the factored form, aren't I? That seems like the easiest version, right? What is it? Sine of 2. Okay. I'm just writing this down so I have it to work with. Okay. Yeah. Oh my gosh. Okay, is there a nurse here? Yes, is there a nurse in the building? Okay. Why don't you go wash your hands and all that, and I'll clean the desk later. But for now, just go to the bathroom and do what you can, okay? And then we'll put this here to remind you to clean the desk. What happened? Mm-hmm. What'd you do to Gabe, Miranda? Miranda, what'd you do to Gabe?
He did it to himself. In the lunchroom.
He spent so long before
Bye. All right, I'm just getting common denominators here, yeah. Sine of 4 pi over 3. What's the sine of pi over 3? You guys have your chart from earlier? Sine of pi over 3 is rad 3 over 2. And then what quadrant are we in for 4 pi over 3? Do you have a nosebleed too?
No.
Oh, I was like, I'm out of here. All the kids are bleeding all over the place. All right. What quadrant are we in here? Pi over 3. What's in quadrant 2? 2 pi over 3.
4 pi over 2.
Okay, so what quadrant are we in then?
4. That's quadrant.
Okay, so whose is sign positive there?
No.
Oh, good call. You could tell Brooke has a career in health.
I literally told her to clean it. I actually told Sierra to clean it, and she's like, no, I got this. Yes, I did. Did you not say to clean the deck? No, I did not tell you to clean the deck. I told you to clean it.
Anyway, all right, so I got negative rad 3 over 2 times, and then what do I end up getting over here? 4 pi minus 21 over 6.
We're gonna be done by 3:20.
What?
Are we gonna be done by 3:20?
I think so. We'll see how much we need to get through in the paper too, right?
Okay.
Okay. All right, so now I've got sine of 2 pi over 3.
Blowing bubbles with gums like.
And then I have negative rad 3 times 4 pi minus 21 all over 12. Okay? Now let's figure out s of pi over 3. S of pi over 3 is going to be the sine of 2 pi over 3 times pi over 3 minus 7 over 2. Sine of 2 pi over 3, what quadrant are we in?
3.
Oh, 2. And then what are we going to be, positive or negative?
We're gonna be hashtag positive.
Oh, yeah.
She's like raging test.
Yes.
Honestly, that's your team.
Who?
Yes, it's supposed to rain tomorrow. And this rain really.
All right, so now I'm going to do this guy minus this guy. Yeah? We following the bouncing ball here? Okay. Do you guys want to see a trick to do this like kind of faster by hand?
Yes.
Okay. So if I have a rad 3 here and a rad 3 here, isn't he kind of the GCF of both? Yeah. Right? So, oh, did my pen just, oh, my pen just died. Okay, try to think about it as factoring out a GCF of rad 3. Sorry.
Oh, 12.
What?
Same with the 12, right?
Yeah, are you okay?
Yeah.
Okay. All right, cool. All right, I think I should be alive again, maybe. All right. So now I've got negative 4 pi minus 2 pi gives me negative 6 pi plus 42. Rad 3 over 12. So then I would have rad 3. You don't have to, anything past this is all equivalent and fine. If you had that, you're good. But I think it just makes like more sense visually if we do 42 minus 6 pi over 12. That one is also okay.
Oh, that's a lot of work.
Or you could have gotten rad 3 with a 6 out front, and then you would have 7 minus pi over 12. These would cancel, and you would get rad 3 times 7 minus pi over 2. Any version of this, we're all okay. All right? How many people were like close, but you got a little lost in the math? Yeah.
No.
I saw a few. Yep. All right.
I was close to a 5. I was close.
All right, here you go. Well, that's good. Light the fire, eh? Okay. Now we're going to go to paper 2. You guys want to go to paper 2? Yeah, yeah. Get that calculator fired up. What? What? Gabe, are you okay? Did you wash your hands?
Yeah.
Okay. All right. I think question 1. Okay, this is not one of the ones where you guys were doing just fine. So we're gonna probably skip one of the other 2 easy ones or something. Okay. This one, kids had some trouble. Here's why. So it says a circle center O and radius R is shown below. The chord AB divides the area of the circle into 2 parts. Okay. Angle AOB is theta. Okay, so we know that if this guy's R, the other radius has to be R as well. Cool, cool, cool. Find the expression for the area of the shaded region. So the area of the shaded region is going to be who made some good composite figures set up here. Yeah, what'd you do?
Yours
Well,
was
I did
bad.
wrong. I did it wrong. I did like too many parts.
Oh,
But I started with a full circle, and then I think you have to do minus.
yeah, sector minus the triangle.
Yeah.
Yeah,
Oh yeah.
sounds good. So area of a sector. Remember, this formula can only be used with radians. I mean, this is in radians, but just a good reminder for the test. So you got 1/2 theta r squared is going to be the area of the sector minus the triangle. Oh my gosh, these are awful. They don't even correspond. There we go. Minus the triangle.
Oh,
So what is the area of the triangle formula?
I like that.
1/2 AB sine C. Some people left it as 1/2 AB sine C. You got to put in as much info as you can, right? In this particular triangle, we have the included angle is theta, and then A and B are R, okay? So if you lost points for that, that's why you lost points. You didn't sub in the stuff you needed, okay? And then that would have just been the formula for the area of the shaded, okay? All right. Then it says the chord AB divides the area of the circle in the ratio 1:7. If you have a ratio 1:7, how many parts do you have in total?
I said you guys.
You got 8, right? Because you've got 7/8 over here and then 1/8 over here. 1/8 over here, okay? That would reduce to a ratio of 1:7, okay? So when you set it up, right, the chord AB divides the area of the circle. This is the area of the circle, yaw, into a ratio of this. So now you would take that 1/8 pi r squared and set it equal to what? The area of the shaded region, because he's the one part, right? Yeah? And then now I see that I'm trying to solve for the value of theta, right? I have an r squared in every part of this thing. So let's pull out the r squared, get rid of it, and we'll try to isolate the theta, okay? So I got r squared over here. R squared from in here. Yeah. Oh, I also have a 1/2 over here that I can factor out. Yeah. And then I'm going to multiply both sides by 2. So now I have pi over 2 pi over 8 is going to be pi over 4. Theta minus sine theta. And then you would just graph in radians to see where those two things cross.
I'm trying to make it
Okay?
like that math.
Do you guys want me to wait for you guys to do it, or are you like, okay, I know how to do that part?
I can do that.
1.77. Yeah?
No.
Okay. Cool. The next one I'm going to skip. Is that okay? I think everyone got it right for the most part. We good? Okay. Binomial expansion, your personal fave. Here we go. So it says find the term in x to the 5th in the expansion of the derivative f prime x. A lot of you guys got this right and I was amped. Good job. Proud of you. Okay. So we have f of x. If we're trying to find the 5th term in the expansion of the derivative, what do you think we should find first? The derivative, right? So let's find the derivative of this thing. It's going to be 7 times x squared plus 3 to the 6th times. I feel like this is the piece people forgot. The derivative of the inside. So now we have f prime of x is equal to 14x times x squared plus 3 to the 6th. So now I'm considering the fifth term in the expansion of this thing. So what I would recommend you do is you kind of separate off this piece, put them out front, and know that whatever you get in here from the expansion of this guy will have a power upped by 1 because you're going to be multiplying by x to the first. When you multiply like bases, you add the exponents. Did you guys get that little piece there?
No.
No? Okay, here, check it out. Look. If I need to get x to the fifth, what is the term that I want in here? When I multiply these together, I'm going to end up getting, what do I need here?
Oh, I just pulled it.
What do I need there in order to ultimately get to x to the fifth? If I know that when I multiply like bases, I add the exponents. I'm going to need the x to the fourth term in there, right? Yeah? Okay. So I'm going to try to get the x to the fourth term in there, and that's going to help me get to where I need to go, okay?
I'm not even on the word
Yoo! Ooh. What was the song we were singing yesterday? Okay, so now I have to find the x to the fourth term in this expansion. Hey, that's pretty easy, right? I can do that. I can find the fourth term in there, right? So what do I want in there? Let's think. Let's go to n crab, yeah? I want x to the fourth. If I want x to the fourth, what do I need here? This is the only piece that contributes to powers of x. N is what? Tell me n from up there. Good, so I'm just plugging in stuff that I see. So I need 2 times 6 minus r to equal 4, because I need x to the fourth. Yeah?
I was only off by 60,000.
What? You were off by 60,000?
Because I did a different.
Oh. What do you want for r? R is 4, right? Yes. Okay. So then now 6 choose 4. This is a calculator question. Quick, somebody find it on your calculator. What's 6 choose 4?
15.
Okay, this is 2 times 2 gives me the fourth, and then 3 to the fourth. Okay, so this was 15, you said? Okay.
What does it even mean? What does 6 choose 4 mean?
6 choose 4. It's the formula, you know, that you have NCR on your formula booklet, and it's n factorial over r factorial times n minus r factorial. It gives you all the combinations when you have a fixed number of outcomes. Like, of these 6 pieces, choose 4 of them.
Alright.
You know what I mean? It's like from probability, kind of. Okay, so now we've got 14x times this garbage. And type all this stuff in your calculator. What do you get? You're going to do this, 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 all times. These are going to become x to the fifth. What's the coefficient?
15,000.
Yeah, good job.
Some new book.
All right, cool. Boom. Ah, this is probably the reason why you came, huh? Question 4.
No, I know.
Everyone did really well. I thought you did a nice job. This is kind of a left field guy until the last part, and then I think we didn't really know what it was asking us. So let's go to A and B, okay? So in A, we just had to find the derivative of f of x. F of x is the sine of 1/2 x. So when you find the derivative, right, the derivative of sine is cosine, multiplied by the derivative of the inside, you now have 1/2 cosine of 1/2 x. Yeah? Cool. Now, when I take the derivative of that guy, that's my second derivative, right? I'm already starting with a 1/2 out front here, right? Okay, think about that. What's the derivative of cosine? The derivative of cosine. Negative sine. And then I have to multiply by the derivative of the inside, don't I? Huh. Okay. What about the third derivative? I already have, she's just saying, yeah. I now have, this is negative, right? What's the derivative of sine is? Cosine, right? So I got negative 1/2 times 1/2 times another 1/2. What's going to keep happening as I take the derivative? Let's find a pattern, right? Oh, actually, this guy remains the same. I don't have to do any further work. But in the second one, what happens? Yeah? Notice what number derivative we have there, too. What derivative is that? The second derivative. And what are we raising the coefficient out front to? The power of 2. Okay. Now look at this one. What am I raising this guy to? Okay, so if you put an answer that looked like 1/2 cosine 1/2 x, negative 1/4 sine of 1/2x, and then negative 1/8 cosine of 1/2x, you got full credit. But it would have been really hard for you to see the pattern moving forward if you didn't break it down like this, okay? Most of you were able to find the derivatives just fine. But when it asks you for the 20th derivative, it's asking you to find a pattern. It doesn't want you to take 20 derivatives of this thing, right? So what I would do here is I'm going to try to see what's happening with the trig function as I take the derivative, right? That's the sine cosine piece that keeps changing. Then I'm also going to see what happens with that coefficient out front as I keep taking the derivative, right? So what would be the, it's like you've got, all right, so you've got the original is sine, right? So what about the first derivative? He turns into what? The derivative of sine is cosine. And then what about the second derivative? What does he turn into? The derivative of cosine is negative sine. And then for the third derivative, what do you get? The derivative of sine is cosine, but now it's negative cosine, right? And then what about the fourth derivative? What happens there? It goes back to sine, right? Because the derivative of cosine is negative sine. There's negative out front sine. So I have returned back to the original at the what derivative? At the fourth derivative, right? What is 20 a multiple of? There you go. 4 times 5. You just go, bro. So it's really the what? The original again, right? That's the trig function part, okay? So I've got that part, right? And then now we have to consider the what? Wait, Miranda, what did you just say? Now we got to figure out the coefficient, right? Okay, so the coefficient in the original is going to be positive because we figured out the signs over here as we were like doing this. Oh my gosh, it just erased my stuff. Whatever, it's fine. Okay. So it's positive, right? But what is happening to the coefficient? What did we say about that 1/2? What's his power?
20.
The number of the derivative, right? So it's 20. Okay, so then this is just your answer. What are we evaluating it at? Pi. So let's plug it in. F of 20 of pi is equal to 1/2 to the 20th times the sine of pi over 2. Oh, wait. 1/2 times pi over 2. 1. Oh, my God. I'm glitching. Okay. X is pi. It's pi over 2. Yeah? I know. I just had a brain fart, too. So what's the sine of pi over 2? 1. So you just have to type this in your calculator. It also accepted this. This is a totally fine answer. That's fine. But then I think the answer that you got if you typed it in was this also. I think, Jack, you were very close, but you had something off about
I
it.
made it cosine instead of sine.
Ah, that was it. I was like, oh man, you almost got it. Okay, so you could have had that or you could have had that. Now let's talk about the next part. It says, evaluate from n up to infinity.
I don't even know
F of the nth derivative of pi. Okay, so what I'm doing here is I'm going to take the first derivative of pi, so that's when n is 1, and I'm going to add it to the second derivative of pi, And then I'm going to add it to the third derivative evaluated at pi. And let's see if we can find a pattern. We're going to continue with this on to infinity. Do we know the infinite sum of an arithmetic sequence? No. But we do know the infinite sum of a geometric sequence. So let's try to find those terms. Let's try to see if we can identify r. And then let's try to see if we can plug it into the infinite sum formula, and we will get our answer. Okay? So let's go ahead and do that. We've got f prime of pi is going to be my u sub 1. What are they? Oh, I want to use them every year, so I want to say no. Is that okay?
This is the latter half. Yeah, there's the third sophomore. That's it.
Okay. All right. Actually, it's fine. It's fine. Because I feel like the people who already left, I didn't tell them, so they probably took it anyway. Okay. Yeah.
No, they put it back.
Oh, they put them back?
Yeah.
All right. You could take it. Just take it. It's fine. Just remember to bring it back. Okay. All right. So can you guys start figuring these out just for the purposes of time?
Where's my calc?
Here, you first row are you're gonna do f prime of pi. You're gonna do f double prime of pi. You're gonna do f triple prime of pi, and then I'm gonna do f to the fourth of pi. Okay? What's going on? You're just finding like, oh no. So you're looking up here, right? So you're gonna. I think I just stopped recording this. Oh gosh. No, I'm good. I'm still recording. Okay. So you would be like, okay, so f prime is cosine. And then there was a 1/2 out front, right? So now you're just putting in the pi. This guy's going to be 0.
Yes, that's what I got.
And then because there's pi over 2 for this one too, and he's cosine, right? The third derivative is cosine. He's going to be 0 also. So now we kind of just have to figure out this one and this one, because these are the only ones that are contributing to the sum. So we're going to neglect the 0 terms and select only the terms that yield a sum, because otherwise it's not going to affect the sum. Does that make sense? Right? No, I need. Oh.
The second one.
Yeah, that's what I got. I got negative 1/4. Good job. Okay. I was like, wait, what? Okay. And then for the fourth
Negative
derivative of pi,
Just 1/16.
1/16. Yeah. Okay. So these are now the new terms in our infinite geometric sequence. This is such a nasty question, but I love it. Okay, so the first term is negative 1/4. The second term is 1/16. How do I find the unknown r? Second over first. Go ahead, type it in your calculator. Tell me what r is.
Negative 1/4.
And then now I'm going to plug it into my infinite geometric sequence. The first term is negative 1/4. This is 1 minus negative 1/4. Plug it in. Were you close?
No.
Oh. Go ahead. Tell me what it equals. It's going to be 1 plus 1/4. That's 4 over 4. That's 5 over 4. Negative 1 over 4. You cancel the 4 is negative 1/5.
Yeah. 1/5.
Woo. All right.
Did
Let's
anyone
go
get,
to-
like, full credit for number 4?
No, nobody got the last part. A few of you were super close, but were you super close?
I was close, but I didn't think to make it like a geometric sequence, like the non-zero terms.
All right, cool. Let's go to question 5. Okay.
Oh, this was.
Yes. Okay, so eliminate the emotion from this, right? When you get probability distributions, and they give you 2. One of them is like P of X, the other one is P of Y, right? And then they're usually going to give you, as the final piece, putting it all together, some version of the expected value that you have to calculate, right? You're going to take the weighted probabilities of each outcome by multiplying them together. They usually make you solve for a clue, and then you use that clue to find the expected value, okay? This is the formula that they follow, okay? So let's figure out how to do it. And then they throw some tricky stuff in here, and these are some tricky questions. It says bag A contains a large number of tokens. Each token is numbered 1, 2, 3, or 4. A token is selected from the bag, and the following table shows the probability distribution of the score X obtained. Okay, so find the value of P. We know that in a probability distribution, the bottom row all adds up to 1, right? Did everyone in here get P equals 0.3?
Yep.
Okay, great. So we're cooking with that. Set it equal to 1. You can graph it for the solutions, and you end up getting P equals 0.3. I think the other solution you end up getting is over 1 or something. It doesn't make sense in the context of the problem, so you would reject it, right? Okay.
Oh, yeah.
Yeah. And then, so hence find the expected value of X. Did you guys multiply these two together and then add them all up?
Yeah.
Did everybody get 2.29 in this room? I think most people got this stuff right. Yeah? Okay.
I've never done that.
Were you like the only person who got the one wrong? All right, so the expected value of this guy ended up being 2.29. Okay. Now, let's do bag B, okay? Bag B is the same idea here. They have the same outcomes on those tokens. Ooh, ding, ding, ding. They're going to be asking you to equate these two. Get ready. Okay. So it says that we've got Q for 1, Q for 2, S and S for 3 and 4. State the range of possible values of S. Okay. Range of possible values of S. So S would be at its maximum when Q is at its minimum. Couldn't you have a probability of 0 for that outcome? 1 and 2? You could get no 1s and you can get no 2s, right? So let's see what happens when, this is like the overarching,
I swear to God, I had this written down.
this is like the overarching relationship, right? So now when Q is 0, what would S be? S would be 1/2, right? Now let's think about if the minimum value that Q can have is 0, what's the minimum value that S can have as well? 0. That's it.
I don't know how I don't know why.
I don't know why I erased that.
I don't know why, but I remember.
I saw you guys like fighting for your life on this question, like cross outs, just like.
Like, there's no way, like, I would have been able to, like, figure that out even though it's only like 3 points. I feel like I remember looking at an answer key mid-test.
Wait, what?
But, like, I don't know why. Like,
I'm sorry, what?
no, it's just like,
Miranda Shun. Okay. Now it says, hence, find the range of possible values of the expected value of y. Okay, so let's think about where the expected value of y would come from, right? Okay. So if Q is at its minimum, what would the expected value of y be? Let's think about it, right? So if Q equals 0, right? What would the expected value of,
you do 3 times 1/2.
you would have 1 times 0 plus 2 times 0 plus 3 times s plus 4 times s, right? And when would, so we're trying to find kind of like the maximum possible expected value and the minimum possible expected value. If the two highest score tokens are the only ones being included, do you think this is going to be the max? Or when we have Q with a 1 and 2 would be the max?
This is a min.
This is the max because it's weighing the highest score of the token. Did that make sense in my explanation there? Yeah? Okay, so like think about it, right? So look, if this was canceled, wouldn't we have a higher expected value if we're taking the 3s and the 4s? Versus if these were canceled, this would be the lowest expected value, okay? Better? Okay. All right. So what did S end up being when it was at its maximum? 1/2, right? What?
Oh, that's like
Oh, what?
3.5.
It would be 6.
7.
What?
6, 7.
No. Wait, is it? Hold on. I can't think. It's 6 over 2. It's 7 over 2 plus
Oh, yeah.
9 over 2. No, that's not right. What?
You're complicating.
I thought it was
I'm
70
not.
times 1/2 plus 4 times 1/2.
Yeah, that's what I'm doing. Why can't I think? Oh my God, it's 3 over 2 plus 4 over 2. Hi. I need to go home. Okay, so now I've got 7 over 2. Hi. Okay. So that's if we have our maximum, right? That's the highest it could be. What about the lowest it could be?
0.
Do the same thing. But like,
Well, let's think about it, right? We're going to do the same thing, right? This guy's 0. If this guy's 0, what does Q have to be then? Remember, it's two S's plus 2 Q's equals 1. So these have to be 1/2. So now what would it be?
whatever that is.
It would be 1/2 plus, it would be 3/2.
Yeah, 1.5.
Yeah. All right, so those are the range of the expected value. All right, okay. And then for the last part, it says a token is selected simultaneously from bag A and bag B. This is where we're now combining the probabilities, and we're like, oh, okay. The probability of obtaining tokens showing the same score is equal to 0.24. What same score, okay? So the probability of getting a 1 in the first bag is 0.3. The probability of getting a 1 in the second bag is Q, 0.3 Q plus. The probability of getting a 2 in the first bag is 0.3. The probability of getting a 2 in the second bag is Q.
Yeah.
Is everyone okay? And then I have 3 is going to be, oh gosh, we have to figure these out. Okay. 0.3 minus 0.3 squared, 0.21, and then 0.19. Okay, so we have 0.21 times S plus 0.19 times S. And this is all equal to 0.24. So it's saying the combined probabilities are going to be equal to 0.24 for the same score from both bags. Yeah? Now, I only have one equation, but I have 2 unknowns. What do you think I should do with the Q? I should rewrite it in terms of S, right? And how can I do that? I'm going to go to the equation that relates the 2. So I'm going to solve for Q in terms of S. What is going on upstairs? Oh, wait, no. I want to do this. Yeah? And then what do you think you should do with this gigantic equation with fractions? Should you try to solve it by hand or end solve? Go ahead, type it into end solve while I'm finishing this. So this is all a means to an end. I'm figuring out what S is so I can ultimately choice C. Calculate the expected value of Y. Why are you neon red? Oh God, what is happening over there?
No reason why. I feel like it's because of me, so no.
Anyway, what do you guys get for S? You're still typing it in. Okay.
How do you find it?
What? End solve menu 3 1. Darwin, are you sleeping? What?
I also
What did you guys
I
get?
remember the time that you got annoyed during advising because we were playing the wrong music and you had it with you.
I have a hole in my head. I was visibly, I was shaken. I was so mad. I was like, why are they playing music?
You have your mean voice on, so you're like, oh, it's actually.
All the voices in my head agree that S is equal to what? Not 7. 0.3, right?
Yeah.
Okay.
I just typed that in and 9 grew to work.
Did you forget to do comma S at the end?
Oh yeah.
She goes, yeah. Okay, so now that I know that that's 0.3, or no, it's 1/2 minus 0.3. Oh gosh, okay, this is 0.3, this is 0.3. Can you guys do 1/2 minus 0.3 and tell me what that's going to be? It's 0.5 minus 0.2. So now you would do 1 times 0.2 plus 2 times 0.2 plus 3 times 0.3 plus 4 times 0.3, and that's going to give you the expected value of y. Okay? See, is this really so bad? No.
Well, like,
No, you got to get in their head. Like, this is the formula, right? They like, you know?
some of these points I could have gotten. I got this screenshot of 5.
Yeah.
But like these
If you
are
weren't sitting next to someone who was eating a whole box of Slim Jims,
And
you know who you are.